we presented 5 simple problems. The correct answers to all of them is A. How did you fare? The rest of this video explains the reason.
So here is the explanation. So you pick a door. What are the possibilities? You could have a goat or a car. Since the host knows where the car and the goats are, he opens the door always to show you the goat. If in the first instance you pick a goat and he shows you a goat, you know that by swapping you would get the car. Now if you had picked the car and the host shows the goat, you know you need to stick with the original selection. Now, if you know which one you picked, it's very easy. If it turned out to be a goat, you would swap. If it turned out to be a car, you would stick. But of course, you don't know that. But there is a 67% probability that you would pick a goat and only a 33% probability that you would pick a car. Therefore, because the probability of picking a goat the first time is twice as high,
you should swap. Is a married person looking at an unmarried person? You had 3 choices: yes, no, and need more information. You probably selected C, wanting more information. What would you like to know? You would like to know if Mary is married or if Mary is single. Let's take a look. If Mary is married, Mary is looking at unmarried David. And if Mary is single, married Roger is looking at single Mary. So as you see, the answer is yes. You did not need any additional information. Worst, your common sense failed you.
Now 99% accurate means if we conduct 100 tests, 99 of the results would be trustworthy and we would only have 1 false result, positive or negative. So imagine 100,000 people are tested and we create a table. Row A is for those who have the ailments and row B is for those who do not have the ailments. Now we would expect 100 of this 100,000 people to have the ailments because it is 1 in 1,000. And hence 99,900 would not have the ailments. Now because the test is 99% accurate, we would see 99 positive results and 1 false negative. That is, 1 person who actually has the ailment will be told that he does not have the ailment. Fair enough? Now of the 99,900 people who do not have the ailment, 1% unfortunately would be tested as false positive. That is, they would be told that they actually have the disease when they don't have the disease. And 98,901 people would be told correctly that they do not have the ailments. The tests yield 1,098 positive results. However, only 99 are true positives. What does this tell us? If you are tested positive, even with a 99% reliable test, there is only a 9.2% chance that you have these ailments. Yes, less than 10%. And the doctor wants to put you on medication.
So what is Linda most likely to be? A bank teller or a bank teller and a part-time music teacher? Consider this class or group. The number of males in this group, that is satisfying 1 condition, will always be greater than the number of males in this group born in this city, that is satisfying 2 conditions. Hence, Linda being a bank teller satisfying 1 condition will always be greater than Linda satisfying 2 conditions, which is that of being a bank teller and a part-time music teacher. Hence, the most likely scenario is that Linda is a bank teller.
At first glance, it may seem like player 1 has the advantage, since she'll win if any one of 4 numbers is the highest. But actually, player 2 has an approximately 56% chance of winning each match. One way to see that is to list all the possible combinations you could get by rolling 2 dice, and then count up the ones that each player wins. These are the possibilities for the yellow die. These are the possibilities for the blue die. Each cell in the chart shows a possible combination when you roll both dice. If you roll a 4 and then a 5, we'll mark a player 2 victory in this cell. A 3 and a 1 gives player 1 a victory here. Now we can see why the first glance was wrong. Even though player 1 has 4 winning numbers and player 2 only has 2, the chance of each number being the greatest is not the same. There is only a 1 in 36 chance that 1 will be the highest number, but there's an 11 in 36 chance that 6 will be the highest. So if any of these combinations are rolled, player 1 will win. And if any of these combinations are rolled, player 2 will win. Out of the 36 possible combinations, 16 give the victory to player 1, and 20 give player 2 the win.
Many real-world problems are based on data with some degree of uncertainty. Thus, we need to be cognizant of the role of probabilities in our decision-making. As Lee Iacocca pointed out, the greatest obstacle to discovery is not ignorance. It is the illusion of knowledge. Most of us believe that common sense, logic, experience, intuition, judgment, etc. can solve any problem. It is a very dangerous assumption.